Hello, this is Jose Luis here at Parametric Camp and welcome to another video in this series, Advanced Development in Grasshopper. In this video, I would like to show you a really nifty technique to share data and share information across different components in your Grasshopper plugin internally, all right, without having to connect them with wires. And an example that I've built in order to show you is basically some kind of console log sort of object that is basically picking up information that other components might be streaming internally. So what I've done is from the previous video where we were remeshing a mesh, I have incorporated in this component some kind of console write to our internal console a message about the operation that we just did. And what I want to show you is how as I make this operation multiple times, what you can see is that this console is spitting out here like several messages of the success of this operation. And I can clear it and I can say just one and another one and another one and another one and many of them, and they all show up. So and these are not connected. This is happening internally. All right. So I'm using this virtual console in my plugin as a way to showcase this idea of data shared across instances of your Grasshopper components. Okay, this is going to be super easy to do, but it's also going to be a really nice way of understanding how data is managed and also how can you use standard C# development techniques such as static classes in combination with the structures and the templates that you use to develop components in the Grasshopper plugin. Okay, so it's going to be quite nice and nerdy, and always having some kind of console for your plugin is, I think it's kind of cool. Just my opinion, all right? Okay, let's dive into it right now. Let's start with the basics. So as we have been developing all these components that you can see here, you can see that the basic thing that we have done is that we have gone to add, we created a new item, and for every component, we basically use this empty Grasshopper template, which we kind of gave a little bit for granted. And there's a lot of already pre-filled code here, etc., that we haven't really broken down. But the point that I would like to make in this video is that everything that we're doing basically conforms to standard practices in writing C# code in the .NET framework. What that means is that when we create a component, what we're basically doing is we're using a template that is creating a new class, and that class is inheriting of let's say a larger template class that is called the GH component that already has and comes with a lot of functionality to make sure that the component shows up in the screen, that has inputs, that has outputs, that is connected to the engine in Grasshopper that makes component update, etc. And then our only task here is to basically fill in the gaps of how do we start the component, how do we add inputs, how do we add outputs, and how do we write the code that is supposed to execute inside of this component to make all the goodness that we want. All right, that is basically what we've been doing throughout all this playlist. But what I want to say is that even though we're basically using most of the time this super empowered template for Grasshopper component development, we don't have to only use that. We can combine the code that we write in our plugin with standard practices that we use whenever we write other types of code libraries, such as, for example, repositories of code, such as, I don't know, plugins for other environments, etc. So this example that I would like to do in this video is an example where we're going to combine the technique of, for example, keeping track of data in a static way across the entire library using static classes. And we're going to mix match that with this standard practice of just building a library by adding components. Okay? So how am I going to do that? I'm basically, well, first of all, let me remove this component that I just created empty, right? And then what I would like to do is I would like to create a component that is going to be called the P console. It's going to act as a console, very similar to when we say console write line, all right? And then something shows up in the screen when we're writing console applications. What I would like to do is I would like to mimic that feeling, but inside of our Grasshopper library. And then what I would like to do is have one component that will be the P console, and that will output all that text. And what I would like to do is connect that component, that one single component, to all the other components, and have those components be able to stream and output internal data to that component console, to that component. All right. So how am I going to do that? Well, the way I'm going to do that is by first, I'm going to create some kind of, I'm going to call this abstract, but not in a CS, not in a computer science term. I'm going to create some kind of independent console object that is going to be part of my library, that I'm going to call the P console, and that is going to be the one that is going to manage getting data from other components, and that is going to manage offering that data back to whoever is asking for it. All right. So hear me out on this one. So I'm going to go here to utilities, which was that internal section that we had for functions that were not exactly components, basically. So I'm going to go here and I'm going to add a new item over there. But instead of using an empty Grasshopper component, I'm going to use a standard class, like nothing fancy. All right, nothing with that structure. And I'm going to call this the P console, correct? And as I do that, you can see that I have a standard console, doesn't inherit from anything. It's just a very, very simple class. All right. So what am I going to do? I'm going to use standard techniques to mimic the behavior of a console. So what is that going to look like? Well, what I'm going to do is I'm going to create a class that is going to store a list of strings, a list of text, so that if at some point anyone asks for the output of that console, I can just give them all the text that anyone has printed to the console. So the first thing that I'm going to do is I'm going to declare an internal variable that I'm going to call the logs, and I'm going to initialize to empty. All right. So that's going to be a list that is going to accumulate anything. I'm going to call these lines, actually. Anything that accumulates whoever prints here. Then the next thing is I'm going to create a method, and that method is going to be a method that anyone who uses the P console can use to write to the console. I'm going to call it write line, just to really mimic the feeling of C#, okay? So I'm going to create a void method that is going to call write line, excuse me, and then it's going to take an input as a line, all right, as a string. And then what I'm going to do is, whenever someone does that, I'm just going to add that line to my memory, the memory of the console, if you will, which is basically this list that keeps adding. And then I'm also going to create another function that is going to be something like read or something like that. I'm actually going to call it read. And then what I'm going to do is anytime someone asks for this, someone wants to read from the console, I'm just going to return all those lines that have been accumulated. All right. Fantastic. So this is basically a really, really simple implementation of a console object. Now, what I would like to do, this is not done yet for the reasons that I will explain in a second. So what I would like to do now is I'm going to go to remesh, okay? And I'm going to say, remesh is a very complicated operation. I kind of want to get track of what's going on, and I want to print that to the console, okay? So what am I going to do? What I could do is I could say, well, first, let me compose a message that is going to say something like this. Remeshed mesh two vertices, for example, and then remesh dot vertex count, and then plus, and then faces, and that's going to be remesh dot triangle count. All right. So I'm going to create basically a message that I want to print to some kind of console. Okay. And now I would like to print or to write line this to that console. So now here's where the problem and where the interesting trick is going to happen. If I were to say P console, you can see that I already don't have a P console. Okay, so it's not working. There's nothing such as the P console available here, which is kind of strange. The reason why is that P console belongs to this namespace, which we have not imported. So let me go to Remesh and make sure that we are using that namespace. Okay, so that we're loading everything that is part of utilities here. All right, so that's one thing. If I go back down and then I try again, P console, you can see that now it's an object that it's available. But if I click dot, I don't have access to write line, which is kind of strange. Maybe the reason for that is that the class is not public. So let me make all of these publicly available. The class, and let me make also the two functions write line and read, let me make them available. So then let me try again. P console dot, and then, oh, but I still don't have a write line. Why do I not have write line? Well, the reason is that because of how I have designed the console, right now the console is a standard class that basically uses, basically in order to use it, what I need to do is I need to instantiate objects of this class that then I can use to write line and to read stuff. What that means is that because it is a standard class, what I will need to do is I will need to create pconsole objects. By doing this, for example, let me say var pconsole is going to be a new pconsole object, right? And then once I have created an instance of that, then I can do pconsole dot and write line, and I can write my message over there. Okay? Now this maybe feels like it will do the trick, but it will not do the trick. It will not work for the reasons that I'm going to explain very soon. Okay? So, but before I get into why this is not working, let me first make the component that will output that logger to the screen. Okay? So for example, I'm going to go to utility components. I'm going to add a new item. This one is going to be a Grasshopper component that I'm going to call a pconsole logger, for example. The pconsole logger, and then I'm just going to add here to the category pcamp, and then here utilities. All right. It's going to have an input. For example, let's say that we want to add a Boolean that is going to be called update. So if we don't update, we just don't want anything to show up from the console. That's going to be no description, and then Grasshopper parameter access is going to be item. And then the output will need to be of the type text, and it will need to be a list because we may want to output a lot of text from there. So pmanager dot add text parameter dot logs, and then that's going to be L. I'm not going to add a description, and the parameter access is going to be, this one is going to be of the type list, okay? Because the console may give me a ton of text. And then I'm going to do the standard thing where I'm going to retrieve the Boolean. So I'm going to initialize it to false. And then if I don't get it, if I don't get the data that I reference into the update component, then stop executing this component, all right? And then if update is false, then also stop, like don't output anything, all right? But if the output is true, then I actually want to output something. So I'm going to say, let me read logs. Let me read them from the pconsole object. So, okay, so I guess we're going to have to do the same thing again. We're going to go here to pcamp, utilities, etc. We're going to add it here. So now we do have access to the pconsole object, but remember we don't. So I guess we need to initialize this. So I'm going to create object of the PyP console is going to be a new instance. And then from this instance, I'm going to read the text, all the logs, and then I'm going to output those logs. So da.setDataList, the first output, and all those logs. Okay? Beautiful. So it feels like this should work, but it's not going to work. Let me show you why. So I'm going to save everything. I did add the output here to the to the console, etc. And yes, so this is, let me just load the plugin and see if this works or it doesn't. Okay, I'm going to load the components. All right. Okay, so I'm going to go to pcamp, I'm going to go to utilities, and I'm going to the pconsole logger. All right, I'm going to plug here a panel, and I'm going to press here, put here a Boolean toggle. All right, and I'm going to say true. So this should be now updating, right? And so it's not working, but let me see. Let me change this so that I make modifications and I force this component to update a bunch of times. This component has updated several times as I was changing my slider. So I should be getting here like a bunch of those updates, right? But I'm not getting them. So, okay, so this is not working. So why is this not working? Well, the reason why this is not working is because of this way of working with the console. If you remember, the console object, when we're writing console applications, is this one object that is called console, that we don't have to instantiate, that we don't have to create with the new keyword, etc., because it is one common object that is available to any single part of the code that lives in a console application. It's the same object. And because it is the same object, and because it's accessible to everyone, whoever writes to that console ends up in the same place. There's the idea here that that is a unique object that is the same for everyone who is writing something to the console in a console application. That is very different from what we've done here. Because pconsole, because of the nature of this class, because pconsole needs to be instantiated, then what it means is that every time I update the mesh, I create a new instance of a console, I write to this console, but then probably when this function ends, this pconsole object ceases to exist. It expires. It's not available anymore. And on top of that, the problem is also that in my pconsole logger, what I'm doing is I am actually creating a different copy of the console that is not the same console as the console that the remesher is using. They're different objects. So even if these two theoretically were updating exactly at the same time, which is never going to happen, but even if that was the case, they are still two tiny independent consoles that don't share the same data with each other. So that's why even if I read from here, I get nothing, because this object was created right away, was not interacted with by anyone, and then this was just empty. All right? So how do we fix this problem? Well, we use a technique that is very common in computer programming, especially in C#, when we want to share data amongst different processes, which is going to the pconsole object, and then instead of making it a class that needs to be instantiated into objects for those objects to work, what we can do is we can create a static class. I don't know if I have talked about static classes in my C# course in this channel, but if I have, there will be a card popping up on the corner if I've done this. If I have not, then there will be no card or no description in the video, and maybe I have to do this in the future. I forget, okay? But the idea is that static classes are classes that already exist as entities when you define them, and their properties, their static properties, are already available as well without the need for instantiating them. It's basically saying I'm going to create a one-off, but that one-off, as I declare it, it already exists and it's the same for everyone who wants to interact with it, okay? So how does this look like? I'm going to add here the word static, all right? And then basically I'm going to make every single thing that lives in this class also static. The static property, static function, etc. All right? What this means now is that pconsole cannot be instantiated. I cannot create a new pconsole. And actually, probably, you can see that this is already giving me an error because look at this, cannot create an instance of the static class pconsole. Pconsole is just one of, all right? But the beauty of this is that now what I can say is like, well, you know what? I'm going to get rid of this. And then this thing, instead of being, it's going to be the pconsole object itself. Very, very similar to what we were doing in console applications. And this one here, same thing. For the logger, I get rid of this. And then what I want here is just to read from that same pconsole application. Sorry, class, all right? The beauty of this is that there is only one pconsole class. It is static. It's the same for everyone. Everyone in this entire library, in this entire plugin, has access to pconsole because it's a shared one and it's unique. All right. So whatever someone writes to the pconsole, for example, remeshing, will be available to be read from anyone else, such as, for example, the logger. All right. So are you ready for this? So let's run this. I'm going to output this. And I'm going to load this here. All right. So is this working? Oh, let me see. So for example, I'm going to update this component a bunch, but it's not updating anything. Wait, is it not? So if I do false, but if I do true again, what? This thing shows up here. Okay. Wait. What happened there? Jose Luis, do it again. So I'm going to update this component. This should be sending messages here, but it didn't. But if I turn this on and off, all those new components show up here. Oh, Jose, why is this happening? Well, it's happening because if you remember, the way Grasshopper works is that this component, it's only going to be updated, it's only going to be regenerated if any of the inputs change. And since I am changing here, this is not changing anything. This is not triggering an update. So unless I turn it on and off again, this doesn't go anywhere. So a workaround through that can be to just basically say, I'm going to plug in here a trigger, right? That trigger is going to be of 1 second. And then every time I do my modifications here, you see that thing updates automatically. That was very difficult to see. So let me show you again. So I'm going to make some changes here. Pop, 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 and then they show up over time. Every 1 second, the component updates and picks up the new data. All right. Beautiful. And no matter how many components do I have, all the components will always point to the same console object. This one, etc., etc. Something that I may want to do is I may want to add the option here to reset and clean the logger. How can I do that? Well, I can have an option here where I can say static public reset, and then whenever, or clear. I think clear is probably clearer. Clear, and then whenever I do that, then I probably want to clear the lines array. All right. And then static public void, this is going to return nothing, okay? And then in the console logger, I'm going to add an input. I'm going to call this p manager, add boolean, and then I'm going to call this clear, and then c, and then Grasshopper input is going to be an item, and then here I'm going to say another input called clear. I'm going to copy and paste this. I'm going to save that here. And then what I can do is, if clear is true, then what I want to go is to the P console and to clear the console from any data. All right. I'm going to save this. And then we have now a way to empty the console object. Oh, where did this go? Would you like to see them? No, it's probably okay. I probably just need to drop this and drop it again because it's an old P console logger. True. And then a button here to clear. And then the updater and this here. Okay, so I have the two components. And then I'm going to change this a little bit. Boop, boop, boop. You see how that updates? And then I'm going to clear it. And then I'm going to update a little bit. Pum, pum, pum. And etc. etc. Beautiful. So we have a logging mechanism that is now dynamic, and that, interestingly, this is the coolest part. Without actually being connected to any component, it reads data that is flowing internally, let's call it that way, from the components there. I've actually used this trick a lot for debugging, for example, while I was developing for Grasshopper, and it's a very interesting one. Okay, so why not? It's always nice to have like very explicit outputs that let you know what's going on inside the platforms that we're working with. Okay, fantastic. So that was it. Remember, static classes are very useful as a way to exchange data between components and to do interoperability between different parts of a Grasshopper plugin, for example. Okay, beautiful. I think with that, this is what I wanted to cover in this video. Thank you very much for watching. If you found this useful, hit the like button, subscribe to the channel, say something in the comments, join our Discord server, share some of the work that you've done on Twitter, Instagram, whatever. You know how this works, okay? Just show a little bit of love and appreciation digitally. It helps us keep going. Thank you very much, and I'll see you on the next video in this series where, what are we going to do? I think we're going to talk a little bit about testing and debugging techniques for Grasshopper components, okay? For Grasshopper plugins. Thank you. Bye-bye.